given the function f of x equals x to the fourth plus 62x squared plus 128x plus 65, we're going to find all the zeros of this function. So the first thing that I would do is I would always graph it, because the zeros is where it crosses the x-axis. And if by graphing it you can find all of the zeros, so this particular function is going to have 4, it makes the problem a lot easier, and you can just get all the real zeros off of the graph. So what we're going to do is we're first going to import this function into our graphing calculator. So I'm going to show you how to get it on both the Inspire calculator, and then if you don't have an Inspire calculator, we will show you Desmos, how you can type it into Desmos. So just to, this will show you the Inspire calculator. Just open up a graph menu, and we're going to type in the function x to the fourth plus 62x to the second plus 128x plus 65. And we're going to just hit enter and graph it. So this is a nice graph of it. You can see that it crosses the x-axis or possibly bounces off of the x-axis one time here. And so I can go to my menu, and I could, if I want to see a better graph of it, I could go up and I could zoom in or zoom out. So we'll just see here what happens if I zoom in or zoom out. If I want to set my window settings, I can go to menu, and I can go up to my window settings, and I can manually type in what I want. So let's say I wanted like -5 to +5, and then let's do the y-axis, -5 to +5 also. And then might adjust my graph here just a little bit. So right now it's counting by, I just set it at auto, but if I wanted to actually have it count by what I particularly wanted to count by, like ones, I can go change my X scale here to 1, and I can change my Y scale to 1. Hit enter, and I change my Y scale to 1. Make sure I hit enter and hit OK, and it'll change what I'm counting by on both my X and my Y axis. So the next thing I'm going to do is I'm going to hit menu, and I'm going to go to Analyze Graph, and I'm going to find the 0. So for this particular calculator, it makes me do a lower bound and an upper bound. So I'm going to drag this vertical line to the left side of my 0, and I'm going to drag this vertical line to the right side of my 0, and you can see right here where it crosses the x-axis, or it actually bounces off of the x-axis, because it doesn't actually pass through, is -1, 0. So that will mean something special on this graph. That means that actually this 0 counts twice because it's a bounce. Now, another way you could get this graph is using Desmos. So if I go to Desmos.com, if I don't have a graphing calculator, and just hit start graphing, again, I'm going to type in the function x to the fourth plus 62x to the second plus 128x plus 65. Again, I can just click on the 0, and I can see the same graph, and my 0 is -1. Again, this is a bounce. It touches the x-axis and bounces back off. So this is a double root, so this 0 will count twice, and we'll see that here in just a little bit when we start showing our work. So we go back, and what we're going to do is we're going to use synthetic division to find the reduced polynomial. So this particular function is x to the fourth plus, I need to fill in a missing term here, plus 0x cubed plus 62x squared plus 128x plus 65. So in my synthetic division, when I break down my coefficients here, it's a 1, it's a 0, it's a 62, 128, and positive 65. And you have to fill that missing spot in with a 0. If you do not fill that missing spot in, you will get it wrong. So on my graph, remember it crossed the x-axis, or it touched, I should say, the x-axis at -1. So that's what my first 0 is that I'm going to plug in here. So my first 1 comes straight down. I multiply. -1 times 1 is -1. I add. I get -1. -1 times -1 is +1. I add. I get 63. -1 times 63 is 63, negative. I add 128 minus 63 here is 65. I multiply negative 1 times negative 65. Oops, sorry, I didn't want to change that. Negative 1 times positive 65 is negative 65. I add, I get 0. So my remainder here is 0, which is what I expected to happen because that showed there was a 0 on the graph. So the next thing I have to do is, this is now a reduced polynomial. This polynomial is 1x cubed minus 1x squared plus 63x plus 65. Now, if this was not a bounce, what I would do is I would go back to the graph and I would hopefully be able to see another x-intercept. But since this one is showing a bounce, this is root is counting twice. And so I'm going to use negative 1 again as my synthetic division. But this time I'm going to divide it into my reduced polynomial. I'm not going to go back up to the original. So in my synthetic division, I'm going to have 1, negative 1, 63, and 65. I'm going to use my 0 of negative 1 again. Again, the first number comes straight down. So negative 1 times 1 is negative 1. I add, I get negative 2. Negative 1 times negative 2 is positive 2. I add, I get 65. Negative 1 times 65 is negative 65. I add, again, I get a remainder of 0. So this time, my reduced polynomial is, it's going down by 1 degree each time, is 1x squared minus 2x plus 65. Now, this graph does not show any more real zeros. So the remaining two zeros have to be imaginary. So I need to solve this a different way. So I'm going to use the quadratic formula to solve this. So the quadratic formula, if you don't remember it, is negative b plus or minus b squared minus 4ac all over 2a. So I'm going to sub in here. So a in this case is 1, b in this case is negative 2, and c is 65. So subbing in, I'm going to have positive 2 plus or minus negative 2 squared minus 4 times a times c all over 2 times a. So this becomes 2 plus or minus negative 2 squared is 4 minus 4 times 1 times 65. So 4 times 1 times 65 is 260 all over 2. So this becomes 2 plus or minus the square root of negative 256 all over 2. So I need to break down the square root of negative 256, simplify my radical. So I need to find a perfect square root that goes into 256. And 256 is, first thing I would do is just check to see if it is a perfect square root, and it is. So the square root of negative 256 is the square root of 256 and negative 1. This is actually 16, and the square root of negative 1 is I, is our imaginary number. So my problem is becoming 2 plus or minus 16i all over 2. So this will reduce. As long as these three numbers all divide by the same thing, we can reduce this. So this will reduce to 1 plus or minus, I'm dividing them all by 2, 8i all over 1, or just simply 1 plus or minus 8i. So my four zeros are negative 1, negative 1, 1 plus 8i, and 1 minus